Okay, today we're going to talk about ions that are made up of more than one atom. And I know at GCSE these often uh, cause confusion. Probably if you're doing A-level chemistry, then you probably weren't confused by them, but a lot of people do get confused by them. So what do I mean? I mean things like OH minus, sulfate ion, SO4 2 minus, nitrate ion, NO3 1 minus, and let's also have the carbonate ion. Now, when we talk about ions with only one atom, that's pretty easy. So we think of like the Cl, the chloride ion. Well, that's not really very difficult because chlorine we know is in group 7, isn't it? And the chloride ion, well, chlorine has 7 of its own electrons, and it's got a negative charge in it because it's got an extra electron, that one there, the dot, which it's got from sodium or somewhere else, and that the whole thing is negatively charged. We usually draw a bracket around that, don't we? So that's fairly straightforward. But what about all these other ones like sulfate and nitrate and so on? Now, well, let's think first of all, an ion is ions, they're charged. Why are they charged? Because they've got more or less electrons than protons in the nucleus, yeah? Positively charged protons. Okay, so all of these things like the sulfate ion there and the nitrate ion, well, they've got more. Sulfate's got 2 more electrons than it should have. Nitrate, 1 more electron. Carbonate, 2 more electrons. So that's what that bit means. What does the SO4 bit mean? Well, it means there's like 1 sulfur and 4 oxygens. Well, how are those stuck together? How are the sulfur and the oxygen stuck together? Or the nitrogen and the oxygens in this case? Well, they're stuck together by covalent bonds. Okay, so let's just write that. Then in these sometimes called polyatomic ions, more than one atom, the atoms are joined together by covalent bonds. So we've got 2 things going on there. We've got covalent bonding in the ion, and then we've got an extra electron, or an extra 2 electrons, which means it's charged. Okay, so let's have a look at the dot cross diagrams of some of those things. Now, I'm not going to do sulfate and nitrate just yet because they are a bit more complicated, but we'll do them in the next couple of lessons. But we're going to do the hydroxide and the carbonate ions, just to show what's going on there. And it will, if you understand and can draw dot cross diagrams of these, it will help you out massively in the months to come. So here's another one here, which you probably come across, the hydrogen carbonate ion, which we'll also do. That's HCO3 1 minus. Right, let's start off with the hydroxide ion first of all then. Now, we can think of the hydroxide ion as coming from water. So I'm going to draw water. I'm going to draw it like this. Okay, so a dot cross diagram for water, well, we would have there's oxygen, hydrogen, and drawing that hydrogen in red, you'll see why in a minute. We're going to have a dot and a cross there. We're going to have a dot and a red cross for that hydrogen. Then we need to say, right, oxygen is in group 6. I've only drawn 2, so I need to draw 4 more electrons, don't I? So I've got 1, 2, 3, 4 there. Okay, so that is the dot cross diagram for water. We're pretty familiar with that. Now let's think about the dot cross diagram for the OH minus ion. What does that look like? Well, what happens is this hydrogen here, this red hydrogen, that goes, but it leaves its electron behind. Okay, so if I draw the OH minus ion now, all we need to do is get rid of that red hydrogen. So this one hasn't changed. So we have a dot and a cross there. We've got those 4 electrons there. And then here, I've got that electron comes from the oxygen, but this red electron, well, that comes from the hydrogen. Okay, and the hydrogen has left that behind. So you can see, here's the OH minus ion. So we won't put a bracket around it like that, and a negative charge there. Well, we have a covalent bond between an oxygen and a hydrogen, but the overall thing is negatively charged because this oxygen has got 1 more electron than it should have if that electron's come from a hydrogen. And so that's the hydroxide. Another important thing to realize here is that the negative charge, if you like, isn't just sitting on this, it's not just sitting on that electron there. Okay, the negative charge is on the whole ion because you've got so many protons in the nucleus of oxygen, 8 protons there, and you've got 1 there, so you've got 9 protons, yeah. But you've actually got 10 electrons, okay. Well, we've only got 8 on that diagram, so the other 2, of course, are the inner shell of oxygen, which we haven't drawn. But you've got 1 more electron than proton, so overall the thing is got a negative charge, and that negative charge will be spread over the whole of the ion. It won't just be sitting there. Okay, so that's the hydroxide ion. Now let's do the hydrogen carbonate ion. Okay, well, let's do the carbonate ion, right? But before we do the carbonate ion, we need to think about this molecule, which is sometimes called carbonic acid, H2CO3. Now, what does that look like? Well, this is where we need to start thinking about our numbers of electrons, numbers of bonds that things form. Carbon likes to form 4 bonds. Yeah, so I'm going to put carbon there. Oxygen likes to form 2 bonds. So put an oxygen there. Oxygen there, oxygen there. Right, where am I going to put my hydrogens? Well, I'm going to put them there. Okay, I'm going to put 1 there. I'm going to put 1 there. Now, is the bonding going to, if you've got the right number of bonds here, this oxygen is, this one's fine, yeah? That's got two bonds. Hydrogen's fine, it's going forming 1 bond, that's the number it wants. Is this oxygen, this one's okay, it's forming 2 bonds, yeah? This oxygen wouldn't like this because it's only forming 1 bond, okay? And the carbon wouldn't like that because the carbon is only forming 3 and it likes to form 4. So the obvious solution there is going to be turn this one into a double bond. And now we can see the carbon's forming 4 bonds, the oxygen is forming, all the oxygens are forming 2, so everything's okay. Right, so what I'm going to do here is I'm going to call the oxygen electrons dots, the carbon electrons crosses, and we'll use a little, yeah, let's use it. Actually, I'm going to draw these as, red. Make it the same as the other one. Okay. That's just a, right. I'm going to do these as blue dots. I'm going to do the carbons as blue crosses, and I'll draw these hydrogen electrons as red crosses. So first step in our diagram, we draw the overlap. Let's draw these ones as red. Good, I can do that. Right, so Right, so let's do the electrons here then. Right, carbon. Right here we're going to have a blue dot and a red cross from the hydrogen. In the overlap here, we want a blue, single bond, so just a pair of electrons. We have to be careful with this one because this is a double bond, so we want dot cross and dot cross. Now we're on to our step where we count up the number of electrons. So carbon, we've got 4 electrons and there is 4 electrons there, so we don't need to do anything, add any to the carbon. The oxygen, so this oxygen has got 2 there, and it should have 6 of its own, so we need to draw 4 more here. So that's 6 electrons for that oxygen, and this oxygen thinks it's got a full outer shell. Yeah, so that's all good. The carbon thinks it's got a full outer shell, 2, 4, 6, 8. These oxygens are not complete. I've only got 2 electrons. They should have 4, should have 6, so I've got to draw 4 more. So do 2 there, 2 there, and same for this one. Okay, so that is our structure for H2CO3 for carbonic acid. Now, if it wants to form the carbonate ion, what happens is these 2 hydrogens, these go away, but they're going to leave what behind? They're going to leave that red electron. They're going to leave behind. So let's do that. Rather than draw the whole thing, I'll just cross out those hydrogens. So they're gone, but the electrons staying behind. So this is our carbonate ion now. So it's not H2CO3 anymore. It's CO3 2 minus. Right, why is it like that? Well, we've got covalent bond between carbons and oxygens. A double one there, and these are both singles. And the overall, why is it 2 minus? Is because this structure has got 2 electrons which don't belong to it. They came from the hydrogens which have gone away and left their electron there. So that is the dot cross diagram for the carbonate ion. Now you can probably see the hydrogen carbonate ion is extremely similar to that. So if I just turn this into a hydrogen carbonate ion, instead of losing both hydrogens, it's only lost one. So if I put the hydrogen there, so there's the hydrogen carbonate ion. It's only got 1 negative charge on it because of this. Of course, this hydrogen has got its own proton. So that would be the dot cross diagram for the hydrogen carbonate ion. So hopefully you can see there's nothing magical going on with these when you see these rather confusing things written down. You have got covalent bonding between the atoms, and the reason why the whole thing's got a charge is because it's got more electrons than it should have. And if you like, those electrons have come from hydrogens which have now gone away. In a later lesson, we'll show exactly a very similar thing there. The sulfuric acid, the sulfate ion, that is going to come from sulfuric acid. Okay, so those hydrogens are going to leave their electrons behind, so it's SO4 2 minus, and the nitrate ion, that's going to be very similar as well. But nitric acid, the hydrogen goes away, leaves its electron behind, so it's NO3 minus now. Probably important to just to emphasize that, yeah, all of these atoms, they all have full outer shells. Okay, they've all got noble gas electronic configuration in these ions. Okay, thanks.